Hello everyone and welcome to AGACAD's webinar Framing Timber and Steel Walls in Revit. My name is Eve and I am an architect and a BIM consultant here at AGACAD. We create applications for Autodesk Revit based on the needs of world's leading BIM practitioners. We eliminate tasks that do not create value. We develop the widest range of true BIM software in the world for Revit professionals, covering wood and metal framing, precast concrete design, and MEP system design. Today I'm going to talk about our BIM solutions called Wood Framing Wall and Metal Framing Wall. It's for creating detailed multi-layered timber and steel wall framing for your Revit models using fully customizable rules and templates. With the help of our software, you can frame multi-story houses 10 times faster than using standard Revit interface. Then you can generate job drawings and cut lists, perform structural analysis by exporting your wood frames to external analysis software at any stage of design process, and then also export to any CNC machines and production lines such as Weinmann, Randag, Hundiger, and so on. In this webinar, you'll see how to model multi-framing, multi-layered timber or steel wall frames, create sheeting layouts, complex layer connections, make custom framing member layouts composed of multiple elements, generating vertical, horizontal, or mixed sidings, including nailers and secondary frames, distributes connectors, cuts, supports, and other connections, number all elements in one click, and generate material schedules and shop drawings with automated dimensions and tags. As a result, you'll see a multi-layered timber and steel project with custom multi-element framing member layouts and complex LT and M connections, distributed connectors, fasteners, cuts and supports, sheeting layouts, and automatically generated shop drawings with gravity points, tags, and dimensions inserted automatically, also material schedules. So now let's go into the live demonstration. Okay, so I already have a Revit project open, and as you can see, most of the project is already framed, but I have a couple of walls empty, and I will frame them during this presentation. We can also see only the main frame of the project with no additional layers like sidings, sheetings, and so on. So now I will open another view, and you can see that I already have a project created in Revit. It's created out of basic Revit's walls, floors, and roofs with openings added. The connections are created correctly. And then when you have the model, you can use our software to distribute structural framing elements automatically to your walls, also floors and roofs. So before I start, I'd like to mention that it's important how the model is created. So the walls have to be the same size as the future prefabricated panels, so you should split them if you need that. Also, you need to pay attention to the height of the wall, and the software will identify all of the openings, whether they're windows, doors, or MEP openings. The structure of your wall in Revit is also very important. So let's take a look at the structure that I have for my wall. I have 6 layers created, and the important thing is that I have one structure layer in the core boundary. And then you can add as many layers as you need to the exterior and to the interior side of your wall. There are no limitations to that. It's important that you would assign the material, and the thickness of your layer is important because later you will be able to automatically define framing member thickness based on the layer. So now that I have my model already created, I can start to use our software, and it works like an application inside Revit. So first of all, you should load all of the families, and the software will load all of these structural framing elements that you can see are distributed in my model. You can, of course, duplicate these members, change the parameter values. They're fully parametric, so you can expand the library based on your own needs. And I have already loaded all of these structural framing elements in my model, and you can see them in the project browser under families and structural framing. So as I mentioned, you can duplicate these sizes and change the parameter values. You will be later able to add them into the framing configurations. Then when I loaded the families, the software also comes with standard configurations where we can predefine how the elements are distributed. So once you download a trial, let's say, you will already have those sample configurations and you can start to work with the software. So before framing my wall, I have to map configurations to the wall. So now I should open the link wall window. And in the three first columns right here, you can see the wall structure that was created in Revit. You cannot modify it here, but you can only see it so that you would know which configuration are you mapping to which layer in your wall. As I mentioned, these configurations are sample ones. They come together with the software, so you will have them as well. So in the structure layer of my wall, I added the mainframe. And then to the exterior side, I said that I want to add vertical, horizontal nailers, and also siding. And to the interior side of the wall, I added secondary frame and sheeting. This is just an example, as I mentioned, so you can create any kind of wall structure. You don't have to frame all of these layers, or you can add more of them. And then I added the framing configuration. So the framing configuration basically is rules how elements are distributed. These are sample ones that I mapped to my wall layers, and you will see how elements will be distributed according to these rules. And this is the sheeting configuration that I will be using to split the parts in my wall. So for all layers that I want to frame, I clicked on frame tick mark, and right here I clicked on split parts tick mark. And that's it. When the families are loaded, I already have the configurations and created the wall link. Now I can just select the walls that I want to frame, click on frame wall, and all of the framing elements will be distributed automatically. But before that, I want to quickly show you where the configurations are created, and they are created in the framing configuration window. Also, don't forget to ask questions in the GoToWebinar dialog. In the end of the webinar, I will answer them. So in this window, you can see that first of all, I can choose the configuration type, whether I want to create the configuration for the mainframe or nailers or sidings. So let's say that I will choose the mainframe, and this is the configuration name. You will have the sample configuration right here. You will be able to save it using your own name and then modify everything that you can see right here below. All of these configurations need to be created only one time, then they are saved and you can use them in future projects. You can even place them on a server so that all of your colleagues could use them. That means that only one person from the company can create them. So in these configurations, we can create rules how elements are distributed. So for example, here I have vertical studs. I can choose the element type, you can see it here in the preview, and then the spacing of the studs. Then I have the top plates, so again, I can choose the element type for the top plates. I can rotate them or not rotate them. I can also add a top cover that goes above the top plate, and the same goes for the bottom plate as well. I can choose a different element type, the alignment of the element, and add a bottom plate pad that goes below the bottom plate. We can also add offsets around our wall framing, so each layer can have a different offset. For example, in my case, you can see that the main frame will be lower than the other frames because the main frame will act as a support for my floors. Then we have opening framing, and we can create different configurations based on the category of the opening. For windows, doors, openings are for MEP openings, system openings, and generic opening families, and then also for openings that are close to each other. These are very similar, so we can take a look at the window framing. We can also create different configurations for structural and non-structural walls, and also different ones based on the opening size. So let's take a look at the window configuration. And again, right here, you can see that you have a sample configurations that you can save using your own name and then use them in the future. So everything needs to be created only one time. And right here, we can create different layouts for king studs, headers, top supports, sills, and trimmers. So you will see a lot of these windows with grids in our software. That means that the layout is very flexible. Once I choose the element from the table, you can see it's highlighted in the preview. I can remove it. I can add another element. I can choose a different type. I can also rotate the element and align it, let's say, to the internal side of the wall. I can add another element. I can also rotate it, align it, let's say, to the external side, to the previous element start. I can even say that I want to have two of them or add another one. And all of these can be saved to the database, so later you can choose between those layouts. For example, now I can just go back to the default layer that I had previously. And the same principle applies to all of these tabs where you can see the grid, so it's really flexible. Also, we can add other stats like trimmers, top and bottom cripples, and offsets around our opening framing. So when this is created, we just save it, and then we make sure that the correct configuration is assigned for the correct opening size. And the same goes for all of the connections. We can create different configurations for L and V and T connections. And again, we see these windows with grids, so we can create custom layouts for longer walls in the L connections and also for the shorter walls in the L connections. Then we have end connections and T connections for intersecting walls. Also, we can add rib stats, and bridging and nogging is for all horizontal elements that are between top and bottom plates, let's say. So when these configurations are created, we just save them, and we make sure that the correct configuration is assigned for the correct layer in our wall. So again, I can just open the link wall window, and I can see that this is the configuration that I'm going to use for these walls. So now I can just select all of the walls that I want to frame, click on Frame Wall, and that's it. Now the tool will distribute all structural framing elements according to the settings that I created in my configuration. Okay, and after the frames are generated, we can take a look that all of the elements are cut correctly. I have my bridging element right here. These are the bottom cripples and another frame with the L connection and so on. So now when I frame my walls and I think that they're correct, I can just go on and frame all other layers in my wall like secondary frames, sheetings, nailers, and sidings. But let's say if you need to make a modification in your wall, anytime you can do that automatically. So for example, in one scenario, the architectural model changes and we need to move an opening or add another opening, make the wall higher or longer or anything like that, and the frame is no longer correct based on the architecture. Anytime we can use update frame, select any element from the frame, and all framing members will be updated based on the changes made in the architectural model. Like this, you can see the frame was updated and it's correct again. Also, we can make different kind of changes. For example, if I decide that I want to change something in the configuration, maybe the stud spacing or the headers above my openings, anytime I can go back to the framing configuration, change that, and then use update by wall link to update all of the changes based on the configuration. But sometimes also I need to make a change only for an instance of the panel, let's say this one. So maybe I want to modify the header above this opening, but not this one or any other opening in my project. So that means that I don't want to modify the configuration. In that case, we can use the functionality from the Modify tab. And with this, we can modify anything in the main frame. Let's say the amount of top and bottom plates, the spacing, the bridging elements. Then we can modify anything about the opening. Let's say the header, king studs, top supports, or even the wall joints or joint opening framing. So let's say that in this example, I will modify the opening. So I will select any element from the opening, and you can see the same window as we did in the framing configuration window. That means that it's nothing new. You can just change the whole configuration for the opening, or you can modify a single element. Let's say I will modify the header. I will remove this element and say that I want to have two of these instead. Okay, and that's it. You can see now that I have a different kind of header above my opening than I had before, and all elements also automatically cut based on the changes. We can do a lot of more to these frames. For example, if we need some additional elements to make our frame stronger in some locations, anytime we can add additional elements that are impossible to predefine in the configuration. So let's say I can add an additional bridging and nogging between these two studs in this wall panel. So I can use short elements. Let's say I can add one element. I can define the depth by the core. I won't rotate this element. I will cut the bridging instead of the studs. Also, I will add 2 rows, and the offset from the bottom of the first row will be 300, and the spacing between 2 rows will be 200. Okay, and you will see that additional elements will be added right here, and anytime also we can modify or delete these additional elements. And just like that, they are added automatically. The same thing goes with adding additional studs. Let's say that I want to create a double stud right here. So I can choose this one. I can add my stud to the right from the selected stud or from the start of the wall, etc. The spacing will be 45 because I want to create a double stud. I will add one element. This is the type of the element, okay? And that's it. You'll see that I'll have a double stud and all elements will be automatically cut with the newly added element. And also we can align elements throughout the levels of our project. We can cut, delete, move and rotate them, trim and extend them, split elements. So we can do a lot more to the frames. It all depends on your needs. But let's say now that I'm done creating the main frame and I don't want to modify anything anymore. So I'm ready to create all other layers in my walls. So I will continue with only these 2 frames so that it will be faster. And first of all, I will add the secondary frame to the interior side of the wall as I mapped in the wall link. We can distribute all additional layers at once, but I will show them one by one so that you'd see the process. Okay. And it's done. So you can see that I have a secondary frame added to the interior side of the wall. All elements are automatically aligned. And for this panel as well. Now I can also split sheeting parts from my walls. And the sheeting configuration again is created right here. So you will have a sample configuration already loaded in with the software. I think I'll use this one as I remember. And this is the sheeting size. And then the layout, so you can add extensions from the top and from the bottom. You can merge the parts. You can split them parallel or perpendicular to the studs. You can also add offsets around your openings and offsets from different kinds of connections. When this is saved, again, I already mapped it in the wall link. So now all I have to do is select the walls that I want to split parts for and click on split parts. So the tool will create sheeting as parts category in Revit, so we will not be able to see it once it's created. We will have to turn on the parts visibility in order to see the sheeting or paneling layouts in our model. Okay, and it's done. And now you can see that I have the original view in our model, so I have to turn on show parts in order to see the sheeting. I've created a separate view for that so that it would be easier to see. So you can see that in this view, I have show parts turned on, and that is why I can see all of the parts that I have in my model, and I just split them for these 3 walls. So you can see that all sheeting parts were split according to the settings in my configuration. Again, this is just an example, so you can create your own rules for the sheetings. Okay, and now I can go back to the original view and frame all other layers. So I also have vertical and horizontal nailers in the exterior side of the frames. And these layouts have also different offsets. They stand higher than the main frame, like this, because I created the offsets in my configuration. And finally, I can also add the siding and my panels will be complete. So you can see that The main frame is lower for the supports of the floors, and then the nailers extend higher so that I would have um, elements on which you can add the sidings. And finally, I will also distribute the details. So I will go to add modify details, and again we can create our own configurations for the details. We have them right here. So then I can just select elements from the main frame layer for these three panels, let's say, and use add details. Now I can choose the details configuration, so I will add the one with clip angles and bolts. Okay, and that's it. You can see that the connections are distributed automatically based on the settings in my configuration. So they're added also on the headers, on the top and bottom plates, and on the bridging elements, like so. Okay, and I completed the panels. So now I have to number all of the elements in my project before creating the shop drawings. We should start from numbering the walls, and then all of the elements will inherit the wall mark parameter value. And now the tool just numbered all of the walls in my project. So when I will select wall, you can see that it wrote in a mark parameter value for this wall and for all other walls in my project as well. It's important that the walls would be numbered first, and then I can number the parts, so the sheeting elements will be numbered. And finally, we should number all of the structural and structural connection elements. The tool will write in a couple of parameter values to each of these elements. They will know their host and some other information I will show you after it's done. You will need to use this functionality at the end of the project when you frame all of the walls, because it's numbering not only these three walls that I just created, but all other ones as well. So while it's numbering, I want to show you another thing. So I have another project opened right here. And again, I will just frame this wall using the standard configuration. And I want to show you how flexible the custom layouts are for the studs, top, bottom plates, and the bridging elements as well. You can create these custom layouts in the configuration, but right now I will show you from Modify tab. So when the frame is created based on the configuration, anytime I can go to Modify Frame, select any element from the frame, and you'll see the same thing as we saw in the framing configuration. So nothing new here. And now let's say I will create a more complex situation for my frame. So I will create a double stud. Let's say I will change the type of this element to this one. So I will align this element to the internal side, this element to the external side, to the previous element start like this. Then I can also modify the top plate. So instead of two elements, I will add only one, and I will also add a top cover type. So my top cover will be, let's say, smaller than the top plate. So maybe I will add this one and align it to the external side of the wall. One element will be added. I will keep one element for the bottom plate, and I will also add a bottom plate pad. So I will choose this element and another one like this. I will align this one to the external, this one to the internal side, to the previous element start. Then also bridging and nogging. I will use short elements, but I will also rotate them. I will add two rows and I will align them to the external side of my wall. And then I think that's it. I will click on OK, and you will see that my top bottom plates will be modified. Also, I will have double vertical studs, double bridging element that will be rotated and aligned to the external side of the wall. So it's really flexible to create these complex situations in your frames. And as I mentioned, you can create them in the framing configuration. So you can see that I have a double stud right now. The bridging is aligned, and this is the top cover type. Also, we can see that some elements are built on site, so they will not be included into the framing assembly automatically. like this. So now I think I can go back to my previous projects already. All elements were already numbered. So the tool just wrote in all of these parameter values to my elements. So you can see that this is a vertical stud number 1, that it's located in the main frame and it belongs to the wall number 4. We can also see the framing number, cut length, and the mass is calculated. We'll see all of these sort marks appearing automatically in the shop drawings. So now when all elements are numbered, I can create the shop drawings and schedules automatically. So I will go back to the drawing configuration, and there I can create views and schedules. And again, you will have a couple of sample configurations that come together with software that you will be able to modify according to your own needs. So in these configurations, we can predefine what kind of views we want to create, whether it's a 3D view, elevation, plan, or section view. Then we can write any kind of name, choose a framing layer that we want to see in that view, then a view template that comes from your standard Revit project, the dimensioning rule that can be modified so all of our elements will be dimensioned automatically. Then we can also add a tag for the framing and for the sheeting, and then the schedules, so that all of our elements, structural framing and also connection elements, would be calculated automatically. And finally, we can create any number of sheets. In this example, I will create only one so that it would be faster. So after the configuration is created, I can just click on Create Assembly, then select the wall, choose the configuration for the shop drawings. So now it's creating an assembly for wall number 2. And also while it's creating, I can show you that the same thing applies to our metal framing solution. You can see that this is a project that was framed using metal framing wall plus. And the tool looks very similar to our wood framing metal solution. So this is our wood framing wood solution. This is the metal one. So you can see that it's the same, except that it doesn't have functionality for creating log walls. So everything else is the same. We create the wall link, then we frame the walls, and all elements are distributed based on our configurations. Now we can see that the assembly for wall number 2 was created, and I can find it in the project browser under assemblies. This is the wall number 2. So all of these views and schedules were just generated automatically with our software. So we can take a look what has been created, and we have a 3D view, also the assembly front view, a detail section view. You can see that all elements are automatically dimensioned. You can modify these rules. Then the frame front view. You can see the framing member marks are placed on the tags automatically. We can also see the gravity point is added, and all elements are dimensioned. Also, we can see the structural connection elements here. We can tag them as well if we need to. Then this is the framing and sheeting view. You can see the sheeting is here, the frame is behind it. Also, the sheeting is dimensioned and tagged. This is the framing line detail and horizontal nailers. So I created all of these views in the shop drawing configuration. Then the vertical siding, and finally we have the schedules. So all elements can be calculated in the whole panel, in the material takeoff and assembly part list, and also then we have schedules for connections. Let's say all the anchors and clip angles are here, and then schedules for individual framing layers. For the main frame, we can see the framing number sort mark. Each element is calculated, the cut length is here, and even the framing number mass is calculated based on the density parameter that is assigned to the material of the wall layer. And then the same thing for all other layers in my assembly. So finally, we can create a composition on the sheet. So let's say that I will add the frame front view right here. Then I will add the frame and sheeting view on the bottom. I can also add the framing line detail. Okay. Then I will add the detail section view. So now I am creating only one sheet, but as I mentioned, you can create as many sheets as you need for one assembly. And let's say that this is the layout of my sheet. So now I can go back to the drawing configuration and I can say that I want to use this sheet as a template for my future walls. So that means that I will not have to create this manually again for all other panels in my project. Okay, so I will go to the sheets and I will say that this sheet that I just created for wall number 2, this is the one. I will save it, but I will want to use it as a template. So now when I will create an assembly for another panel, let's say this one, not only all of the views and schedules will be generated automatically, but also the sheet with the same layout that I just created for this panel. And while it's creating, I will go back to my metal project again, and I will show you that the same thing applies to the metal. So once we frame all of the walls, we can see that the schedules are generated as well, and the shop drawings. So this is the 3D view, the assembly front view, the section view. Then we can see also the frame front view, where all of the elements are automatically tagged and mentioned. The gravity point is here. Then the section view. And finally, also we have the schedules, for example, for the whole assembly, where we can see the part list. Then we can see all of the framing numbers. And finally, then we can create a sheet using a layout. Then we can assign it as a template and create all other sheets automatically. So the same things applies to the metal as well. Okay, and I think that it's done. So now we also have an assembly for wall number 3. We can find it in the project browser under assemblies. And again, the same thing. So we also have the same views that we did before that are automatically tagged and dimensioned. And the same thing goes for the schedules. But now I also have a sheet created automatically for me. So before we created the sheet manually and I just created this layout. And then for all other panels, I map this as a template. So you'll have everything created automatically. And this is the basic workflow of our wood and metal framing solutions. So now I will quickly go back to my slides. And now I would like to encourage you to download a free trial of our software. So you can do that by visiting agacad.com, and right here on the bottom right of the page, you will find free trials. And in the overview, you can read about what is our tools for BIM doc. This is a short introduction. Then also we have a Getting Started tab with a lot of useful information about installation and activation, some step-by-step tutorials. And finally, in the Download tab, you can choose the Revit version that you're currently working with and download tools for BIM doc. This is also a really useful introductional video that you can watch to understand how the tool for BIM doc works inside your Revit project. You can download all of the trials from the tools for BIM doc. Now, my colleague Janos will introduce you about licensing and pricing options. So I will share his screen right now.
So as you've introduced me, my name is Jonas. I'm a sales executive here at AGACAD, and I will give you a brief overview of our pricing and licensing options. At the end of my quick and short presentation, I will also reveal a special offer for all our webinar attendees. So stay tuned and don't go anywhere just yet. It will take just a few minutes. All right, let's start with our license types. We sell the licenses as standalone, meaning that they can be installed on a single workstation and cannot be shared. For those of you who wish to share their licenses with your colleagues or access them from different computers, we also offer network activation service for an additional annual fee, we can put all your licenses to network or server, and that will enable you to share them. We also offer two main licensing methods. I believe many of you are already familiar with them. They are called perpetual license and annual subscription. And the difference between them is that perpetual license never expires, whereas annual subscription needs to be renewed on a yearly basis. For those of you who are not sure which licensing option to choose, here's a quick comparison between the two. The main difference is that perpetual license requires higher initial investment, but it costs less over time, because you do not have to pay for the license itself anymore. You would only need to renew yearly maintenance. So this licensing method is more suitable for those who have constant framing jobs or multiple similar projects that ensures the need for the software for a longer period of time. If you need the software for a short or occasional project, then annual option is the way to go. Keep in mind that you can always upgrade from annual to perpetual license anytime. There's also the visual comparison between the two licensing types in total costs over a period of 5 years. You can see that if you are planning to use the software for more than 2 years, perpetual license is the more cost-effective option. Together with the license, whether it be perpetual or annual, we also include a support plan, which is mandatory for all new users and includes personal online training, expert consulting, as well as technical support. All training sessions are recorded and then shared with you for later viewings. So that is all we have prepared for you today. Let us know if you have more questions for us. I would like to thank you for your attention. Thank you for staying with us till the very end. And we look forward to seeing you in our future webinars. Have a great day, everyone.
AGACAD, building BIM together.